Hello friends, welcome to my channel Code Destination. As we are continuing this challenge, one code one day, and we are taking the topic array. So daily we are discussing one topic with one question with detailed analysis. So today we will take a topic array, and in that we are picking this problem from LeetCode. Problem number 75, sort colors. So first we will discuss about this question. So after that we will think which approach we can use here and why. Then we will write code for that, which following the same approach which we are going to discuss. So basically in this problem we are given an array, nums array, and it has an objects, and there are three colors, red, white and blue, and we are representing this color with numbers like 0 is representing red, 1 is representing white and 2 is representing blue. So basically we have to sort this array, and there are some criteria mentioned like here in the follow-up mention, could you come up with the one pass algorithm using only constant is extra space. So basically in this problem we will try to solve this using constant extra space, like without using any extra space, and we will try to utilize this array itself. Basically we will write like solution in the in place manner. So one solution can be possible, like if I talking about brute force solution. So basically it is very simple, we can just sort by using array sort. So maybe I can write here directly arrays dot sort. I can sort it directly here, nums, and it will run, I guess, because it will just sort that array. And yeah, so you can see here both cases accepted, and if you submit it, so it is also accepted, but it is not our like algorithm, because we are not going to write any sorting algorithm here, because in a question it is mentioned, if you follow in a follow-up mention, we have to follow like one pass algorithm using without using any extra space. So let me share my whiteboard. Let me minimize this. Yeah, so first we will discuss how we can think about the problem. So suppose we are giving this array 2 0 2 1 1 and 0. So basically we have to sort this. So what we are trying to do here, basically we are going to use here two pointer approach, two pointer, which is like very basic approach. Basically it is a algorithm which you have to follow. So I'm going to just explain you how you can use two pointer here. So basically we know like our end result should be something from here to here 0. First we have to store the 0, all the 0, then we have to store all the ones, suppose here all the ones, then you have to store all the 2s. Okay, so there are only three possibility. It is also mentioned there are limitation in the array. There are only array only contains 0, 1 and 2. So we already know that, so we will utilize this concept as well. So what we are going to do, we'll like use two pointer. First pointer is which is indicating till where we store the zeros. So I will use this pointer here, and one pointer which will represent till where we store all the 2s, and in between like whenever you like we stored all the zeros here, all the 2s is here with the proper manner, then automatically whatever the remaining will be here. So we will only focus on like storing zeros and 2s on the proper place. So for that we are storing we are using the two pointer. One is which is indicating that zeros is added till here, and the second pointer is 2. So this 2 pointer which will indicate that that number of 2s is stored from here. So let me run that. So suppose for 0 index, suppose I am running the one loop here. So suppose I is 0. So what will be the case, and I initialize 0 like this pointer z pointer as a 0 index, because it is start storing zeros from 0 index. And this 2 pointer I initialize, suppose this array length is n, So I initialize as a last and -1 because we are using zero base indexing here. Okay, so for I equal to 0, if I iterate that, so what will be the case here? Suppose I am taking this array. So for I 0, our I will be here, and our Z indicate this, like there are no 0 because Z indicate that till where zeros are stored, so there are no zeros stored, so it indicating 0 index. And there are one pointer, two pointer, which indicate that from right side till where we stored all the twos, so it is here at the last position, so there are no twos present. Okay, so yeah, if I equal to 0, like our I index is at the 0 position, so I will check. If it is 2, then I will store this at the right position. So what is the right position of this 2? This is the right position of 2, which indicate this pointer 2. So what I will do, I will swap ith data with the 2 pointer, like this t pointer, where it is indicate that where we can store the 2. It is the right place of storing the 2 element. So after that, here 0 will come because this 0 will swap, and this 2 will go at the right place. Okay, so here it will represent like that. And whenever this 2 is stored here, I will move my pointer, t pointer, just here, which will indicate that from right to here, this till this index, there are all the elements stored 2, and my Z pointer is still here. Okay, yeah. So and once iteration is done for I plus 0, I will move I equal to 1. So if I will be 1, so my I will be now here. So I will check for this element 0. So it is a 0 element. So what the right place for this 0, which indicate this Z pointer. So I will swap this 0 with this 0. So it will swap and it will look like that, 0 0, because this 2 will go here and this 2 will go here. So it will be last state of this array is this one, where this 2 pointer is here, and now I move to here 2, and our Z, whenever we store this Z, so I will move my Z index here, which will indicate that from left whatever element is stored is total 0, because next pointer, next index for storing the next new Z, new 0 is this index. That's why it is indicating that. And this next pointer for storing 2 element is this index, so this t pointer indicating that. So now I is equal to 2, so I will write here. So what will the state of now? Here I have 2. Okay, my 2 pointer is here, and I am this position. I will check for this element. So this is 2. So what is the right place for this element? It is here, which is indicating this t pointer. So I will swap this element with this element now. So what will be the state now? 0 0. Now 1 will be here and 2 will be here, and whenever I store this 2 at the right place, I will reduce this 2 pointer here, because next place for storing 2 element is this index, and my Z index is already here. Okay, and whenever I deal with I is equal to 2, I will move I is equal to 3. Okay, so whenever I is equal to 3, what is the state? 0 0 1 1 2 2. So my t pointer is here, and I is equal to 3 here, and my Z index, Z pointer is here. So at this instance we can understood, like this t pointer represent, like from right to this index there are total element which is stored is 2, and from left to this index whatever element is stored as 0. So basically this 2 pointer, what it is doing, it is monitoring till when we stored all the 2's and all the 0's. So basically it is monitoring, and whenever this condition happen, like I less than or equal to t, basically 2 pointer, so we'll stop this iteration. Why? Because at this index we can see all the element is sorted, because all the zeros whatever we want, we are stored here, we can see, and all the 2's whatever we want is stored here. So unnecessary, we don't want to iterate after that. We only iterate till all the 2's and all the 2's is on the right place and all the 0's is on the right place, and whatever things is remain, it automatically come in the at the right place. So this approach we are going to follow in our solution. So let me write the code so that you can connect and understood the concept as well. So here I will take two pointer. One is 0, which will as a 0 index, and the second pointer is t, which indicate from where we can store the 2. So it is in length -1. Okay, so till when my loop will run, so I will take I pointer 0, and my I pointer till when it will run, I less than and equal to t, whenever it reach till the 2 pointer. Okay, so what we're going to do, I will write one swap function here so that we didn't written the logic again and again. So I will take here nums and a index and b index which I want to swap. So what is the basic logic of swap? I will store the ath value first so that we can overwrite, and I will overwrite the ath value with the bth value, and after that whatever value on the b index I will take that previous. So it will basically swap that. Okay, so here what is the case, what case we handle in the explanation? If my nums dot I equal to 2, so what I have to do basically here, first you have to reiterate that loop. So I just at the last I will move I plus plus, so it will iterate. And if the element is 2, so what I have to do, I have to swap nums with ith element. I have to swap with the which element, that 2 t pointer, because t represent the till from right till when all the 2's are stored. So here I have to swap, and once I have swap, I have to reduce the 2 pointer. And what the second case, if nums I equal to 0, it means if it is 0, then what I have to do, I have to swap it, that nums array ith data with which index, which represent all from left till when all the 0 is stored. So here I have to write z, so and whenever it swap, I have to move my z index. So in this way we can like write this logic. Let me run it, and I guess it should run. Yeah, so it accepted both cases. Let me submit it. Yeah, so they are giving wrong answer. Okay, let me understood why it is giving, and we will see what modification we need. So let me take this example. Okay, so I have to remove this one. Suppose I am removing this because this logic already implemented in the code. Okay, so for this test case, maybe I can take this one. Okay, so if this is 2 1 2 and our expected output is 1 2 2, it is expected one, but what we are getting 2 1 2. Okay, why we are getting? Because suppose my 0 pointer is here and my 2 pointer is here, so it will check if it is 2, so it is swapping this 2 with this 2. So if I is equal to 0, in the same manner I am doing. So here this 2 will come here, and this 2 will go here. Okay, so here I and 2, my I pointer move here. So for I is equal to 1, now it is checking, it is 1. Okay, so it is 1, that's why, and my t pointer will be go here because it is swapped. So t pointer go here, and I equal to this t, so it will check it is 1, so it will doing nothing. Okay, so for this case it is giving this output. According to our logic it should give, but it is wrong, that output should be here. Why it is happening? Let me discuss why it is happening actually. So what is going on here? Suppose I am taking one example. Suppose here 2 1. Okay, suppose here 210. Yeah, suppose I'm taking this example. So okay, no, that one. Suppose this example I am taking 021. Okay, so what is happening here for zeroth? Suppose it is coming here 0. So no, that one, no, that is not a right example. So maybe, yeah, same example we can see. So like whenever this 2 is coming, so we can understood whenever this 2 is coming, it is swapping the t whatever data are at the t pointer with this. But whenever it swap, that I index go here. So like after that we can't deal with this element because it is already swapped. So basically this, due to this case, this 2 will never come at the right position. Understood? Because for I equal to 0, this I is equal to 0, we are handling with this data and we are swapping this 2 with this 2 and moving this I. So in the next iteration we forgot this 2, and in the future whatever we did, this 2 will never come at the right position. So basically what we have to do here, whenever this 2 is coming, we didn't have to move our I pointer. Okay, so what we have to do here, I will continue so that ith pointer didn't move. So in that case what happened, like suppose this 2 is coming here. Okay, so this 2 will swap this 2, but my I pointer will be at the same index like 0 because it is continuing, it is not increasing that ith value. Here we can see that ith value is not increasing this ith value, so that's why it is in the swap position. So what is happening, it will again check this 2, if this 2 is this is 2 again, so it will swap this with this 2 pointer. So it will again swap, like this 1 is here and this 2 will come here, so again it will swap this. So we will, in this way we can check multiple time for that same data, because maybe whatever data we are swapping with this, it is not in the right place. Suppose I am taking any example. Suppose this is the suppose this is 2. Okay, and okay, so it is 0 here, 1. So suppose my 2 pointer is here, and suppose this 2, I swap this 1 with 2 in the I is equal to 0 iteration. So this 1 is coming here, this 0 is coming here, this is 2 here. That 2 is at the right place, but in the next iteration, if I is equal to 1, my I pointer will be here, and I know this 1 is not a right place. So in the future my I pointer move forward and we can't make this element at the right position. So yeah, this is the problem here. So instead of moving our I pointer for this case, this 2 case, what we have to do, we will just continue. So for that same element we can check multiple time whether it is at the right place or not, and we will iterate till all the 2's are not at the right place. Okay, in this way I think it should run. Maybe I'll just run it. So both the test cases pass. Let me submit it. Yeah, so it's submitted. It's taking 0 millisecond and beats 100% of users of Java. So in this way we can think. So basically whatever approach we discuss before here, we just modify in that approach because we with the some corner cases here. So we just apply that concept and here we write in the code. So but there are only one case we have to focus. Basically we have to concern and take care about that, like whenever we swapping that element. So maybe with the second element, whatever we are swapping at that position, that is in the right place. So again we have to check that same index. So that's why we are not moving indices whenever we for this case, whenever it is 2. Yeah, so I hope you'll understood this concept behind this question and how we are utilizing the 2 pointer approach. Basically this is called the 2 pointer because there are 2 pointers. You can see Z and T, and we are utilizing this 2 pointer according to the logic. So this is a 2 pointer approach we can use in many questions. You can solve using this approach. So let me discuss about time complexity. So this while loop is taking suppose at most an iteration. Suppose my this nums length is n, so it will take n iteration. So big O of n total time complexity, and they are no using any extra space, and in the array we are doing everything. So that's why it is in place. It is mentioned here, it is in place. It is in place algorithm. So yeah, in this way we can solve this question in a very optimized manner. So I hope you will like my explanation and how we can write the code for that explanation. So if you like, please like my video and subscribe it, so that in future if I upload any further videos, so you can understood the topic and you can solve the question. So thank you for watching my video.